Here's a refresher of your econometric skills that will be useful when you read research papers. Okay, so let's talk about the regression model. We are often concerned with the relationship between x and y. That is, we want to quantify how much y changes when x changes. One way to do that is to estimate the best straight line that describes this relationship. Mathematically, we can think of this as the line being described by beta 0, an intercept, and by beta 1, a slope parameter. So then everything becomes fairly simple. yi is equal to beta 0 plus beta 1 times xi, and we also add an error term which we can call ui. This one will be important in a second. And this is what the straight line looks like. A way to estimate parameters beta 0 and beta 1 is to use so-called ordinary least squares regression, or OLS. Here's where the error term u comes in. We find the betas that minimize the sum of squared residuals. In other words, we minimize the error terms. You can think of this as minimizing the distance between the straight line and the data points. Let's have a look at our graph. This is data point 1, or y1. The corresponding point on the straight line is another y1, but this time with a little hat on top. What is this hat? We always use hats when we talk about predictions that come out of our model. y1 hat is the corresponding point on our straight line for a given value of x1. The difference between y1 and y1 hat is the predicted residual. This is the actual error that we are making by approximating the location of this data point with the straight line. Here's another example. y2 is the second data point. This one is slightly above the estimated line. According to our model, y2 hat would be smaller. And here we have the error term u hat 2. Now it becomes clear why we want to minimize the sum of squared errors. Because there might be positive error terms as well as negative error terms. And by taking the square, we can take care of all of them.